All right, this is the Chapter 5 PowerPoint presentation. Molecules and compounds. So one thing that we need to learn in this chapter is naming compounds. But first, it's really important to understand that elements on their own have one behavior, but when they're put together in a chemical formula, that's what makes them something different. So sugar, like your table sugar, is made up of C's and H's and O's. Those on their own do not act like sugar, but it's when they're all together in the correct formula that make them sugar. So for instance, here we have sodium metal. Sodium is actually extremely reactive. So if you put it into water, it will fizzle up, sometimes catch fire. It's pretty cool. Chlorine is really stinky. However, when you put these together in a 1-to-1 ratio, you have sodium chloride, which is your table salt. So it's putting them together that makes them into what they are. All right, the law of constant composition. This says that all samples of a given compound have the same proportions of their constituent elements. So basically what this is saying is that all NaCl will be 1 sodium and 1 chlorine atom. Water, you'll have 2 hydrogens and an oxygen. They'll always be in the same ratio. Here is the picture of water. You have 2 hydrogens on the left, and on the right you have your oxygen. The 2, the subscript that you have here, that is implying that you have 2 hydrogens. If there's nothing there, we already know that we have 1 oxygen, so you don't need to put the 1 saying that there's 1 oxygen. All right, let's look at these. So we already discussed NaCl. It's a 1-to-1 ratio. We have 1 of each. Carbon dioxide, and we're going to learn how to name these guys later, but CO2, we have 1 carbon, 2 oxygens. All right, this is sugar. You'll have 12 carbons, 22 hydrogens, 11 oxygens. Okay. So that's how it's always going to be, and you can always tell how many of each atom are in a compound based on the subscripts. All right, those subscripts definitely do matter. So if I just say CO, but I'm talking about carbon dioxide, it's actually not carbon dioxide, that would be carbon monoxide. Okay, so carbon monoxide is something that's very dangerous. And CO2 is not dangerous. So you always want to make sure that you have your subscripts correct. All right, when you guys are writing chemical formulas, you always want to put the most metallic element first. All right, the metals are on the left-hand side of the periodic table, and the nonmetals are on the right upper side of the periodic table. Okay, so the more down and to the left, the more metallic, and the more up and to the right, the least metallic. Okay, so notice here for NaCl, we'll always say Na and then Cl, not ClNa. Okay, this is because sodium is the metal and chlorine is the nonmetal. Okay. When you look at nitrogen dioxide, nitrogen is, even though these are both nonmetals, nitrogen is a little more to the left, so we're going to put the nitrogen first and then the oxygen. All right. When you are talking about your nonmetals and which is most and least metallic, here is the order of listing nonmetals in chemical formula. Okay, elements on the left are generally listed before the elements on the right. All right, so even though we haven't learned how to name our ionic or molecular compounds yet, it's important to tell you about polyatomic ions. Polyatomic ions are groups of elements that are put together that have a charge on them that just have a name. Okay, so talk about like maybe acetate ion. So there's going to be a list of polyatomic ions that you guys are going to want to just memorize for your naming. Something important to know when you are doing chemistry is which elements are diatomic. All right, so hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those are your diatomic ones. And basically what that means is these guys will never be just alone. So you'll never just have a hydrogen by itself. You'll never just have a nitrogen by itself. Whenever they are alone, they're always going to be in twos. An easy way to remember these is have no fear of ice cold beer. And it's just the beginning letter of each of that. Each of the words in that sentence that will help you remember that it's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, not particularly in that order for that statement. So we have to learn how to name molecular compounds, which we will do second, and we have to learn how to name ionic compounds, which we will do first. Molecular compounds are when you have two or more nonmetals put together, and an ionic compound is when you have one cation and one anion. All right, a cation is something that has a positive charge on it, and an anion is something that has a negative charge on it. Okay, so you'll have basically one metal and one nonmetal. And I'm going to go over how what the charges are in just a little bit. Next slide. All right, so here is an example of a molecular compound, all right, CO2, and then NaCl is an ionic compound. So in an ionic compound, a metal has a tendency to lose electrons and combines with a nonmetal, which has a tendency to gain electrons. One or more electrons transfer from the metal to the nonmetal, creating positive and negative ions that are attracted to one another. A compound composed of a metal and a nonmetal are considered ionic, and the base unit of an ionic compound is the formula unit. So unlike molecular compounds, ionic compounds do not contain individual molecules, but rather they contain cations and anions in an alternating three-dimensional array. All right, here's just a periodic table that's listed in the slides, and I'm going to talk about it. So basically, all of the elements want to be like the noble gases because the noble gases have a complete octet of electrons around them. Okay, so I'm just going to explain to you what charges everything will become and why. All right, so here's a little better periodic table where you can see things a little more clearly. All right, so your metals, like I say, they lose electrons and they become positive, they become cations. All right, everybody wants to be like the noble gases right here. Okay, these guys are the noble gases. This is everybody's goal to be like this row. All right, so I'm going to explain the charges everything has. Lithium has 3 electrons, okay, in its natural state. But lithium, the cation, will lose an electron to become just like helium, okay? Notice how helium has 2 electrons. So lithium has 3, but lithium will become Li+1 to be just like helium, all right? So look at sodium here. Sodium has 11 electrons, okay? Sodium will lose 1 electron to be Na plus and be just like neon. Potassium has 19 electrons. It will lose 1 electron to become just like argon, all right? So this whole row here, starting with lithium, is the +1 row. Hydrogen they put here, you can kind of ignore it for right now. Hydrogen is odd. It is it's just treated many different ways. So this does not really get included in our +1 row, but these guys do. Rubidium would lose 1 electron to be just like krypton. Okay, so in your guys' little periodic table, if you wanted to write a +1 above this row, that might help you remember that that is your +1 row. These guys become +1 cations. Let's look at this row. This is our +2 row. Beryllium has 4 electrons. It would lose 2 to become just like helium. Magnesium would lose 2 to become just like neon. Calcium would lose 2 to become just like argon. Another word for just like is isoelectronic. So you could say calcium plus 2 is isoelectronic with argon, just a fancy word. All right, so this is your 1 row, your 2 row. Now we're going to skip over to your 3 row. In your 3 row, we're only going to talk about these 2, okay? And we skip over these because these are your transition metals and they have a little bit different issue going on. All right, so boron, this is your plus 3 row. Boron has 5 electrons. It would lose 3 to become just like helium. Aluminum would lose 3 to become just like neon. That's as far as we're going to go down this row. Okay, so when you guys are naming cations, you're going to name them with just the full element name and the word ion. So Mg2+ would be magnesium ion. Beryllium 2+ would become beryllium ion. Na+ would become sodium ion. It's as simple as that. B3+ would become boron ion. Aluminum 3+ would become aluminum ion. Okay, so think about this. What would the name of K+ be? Potassium ion. Good. All right. So we are going to skip over this row. This is kind of an odd row. We don't do too much with these. And we're going to talk about our anions now. Anions are ones that have negative charges. All right, so we have our -1 row, our -2 row, and our -3 row. These guys gain electrons to become just like the noble gases. All right, so we're going to start with fluorine and then we're going to pick it up at the next video. Fluorine has 9 electrons. Rather than losing a bunch of electrons to be like helium, what fluorine is going to do is it's going to gain an electron to be just like neon. So this would be F-. This is Cl-. It would gain 1 to be like argon. This is Br-. It would gain 1 to be just like krypton. Okay. Actually, I think we have time to go into the next one. This is your 2- row. Oxygen would gain 2 electrons to be like neon. Sulfur would gain 2 electrons to be like argon. Selenium would gain 2 to be like krypton. This is your -3 row. Nitrogen, this is N3-. It would gain 3. P3-. It would gain 3. Okay? All right. We're going to pick it up in the next video on how you name the anions. It's also very easy. And then we'll get to being able to put them together in ionic formulas.